We're going to take a look at parallel and perpendicular lines on the coordinate plane. Today in class we've taken a look at equations and been able to take a look and see how we write those. So as I go through the problems, I'm going to explain it a little bit, but understand we'll use some time in class tomorrow. First example I have up here is an example of parallel lines. Above each line I have written the equation that matches that line. If you look at both equations, the equations have the same slope. So on the coordinate plane, parallel lines have the same slope. So since they both have a slope of 1/2, they are going to be parallel. Notice that the y-intercepts are not the same. Perpendicular lines are a little bit different and can be a little bit tricky. If you look at the green line has a slope of -2, and the blue line has a slope of 1/2. They are what I call opposite reciprocals, and that's our giveaway if something is perpendicular. To explain that a little bit further, let's just take a look at the equations without the graph. In the first example, we have y equals -2x. The slope, remember, has to have a rise and a run, so the slope is for this one -2/1. For the next equation that we have, the slope is 1/2, a rise of 1/2. They're opposite, meaning they have different signs, and they are reciprocals. Reciprocal is a word you probably used back in 6th grade a lot. It means to flip. So if you look at the two numbers, they're able to be spotted. What we're going to do next is just take a look at all of these equations here and see if we can determine which ones are parallel to y equals 3x minus 1 and which ones are perpendicular. So I'm going to go through each example, and if they're parallel, I'm going to highlight them yellow, and if they're perpendicular, I'm going to highlight them in green. So let's go left to right, top to bottom. So this first one, y equals 3x plus 2. I notice that this equation has the same slope as the given equation, so it's parallel. Same slope, parallel. Let's look at this next one, y equals 1 plus 3x. Just because the y-intercept and the slope are reversed doesn't change what the numbers mean. The number in front of the x is always the slope, so if the slope is 3, it's parallel. For our next one, we have y equals 2 minus 3x. Now you need to be careful because it's not just a positive 3x, it's a negative 3x. So it's not parallel because it's not the same. And although it's opposite, it's not a flip of the original slope. So that one is neither. Over here now, we do have a negative and it's flipped. Remember, if it's 3x, it's really 3/1x. So I'm going to move the green highlight over to this one. They have opposite reciprocal slopes. If I look at the last three examples, none of them are parallel or perpendicular. Based on what I've already chosen, the slope has to be 3 in order for the lines to be parallel, and the slope has to be -1/3 in order for them to be perpendicular. To make sure that you understood the differences with the slopes, I have two questions that I'd like you to think about and bring with you to class tomorrow. So the first question says, what is an equation that is parallel to y equals 5x minus 3? Now, I'll just warn you, there will be more than one correct answer for this, and we're going to share all of them. Number 2, what is the equation that is perpendicular to y equals 2/3 x plus 5? So come up with some solutions to this. We will talk about this at the beginning of class on Friday.